Hi children, how are you all? I hope all you are fine. Children, in that previous video what we learned more about that fractions we learned. Just we recall that concept fractions. Now in this video we are going to discuss about that our concept that is rational numbers. Okay. Now here see that what about that rational number and what is the definition of that rational number. What is the definition of that rational number here? A number which can be expressed, in the form of P by Q. What is that? A number which can be expressed, in the form of P by Q. P by Q, where P comma Q are integers. P comma Q are integers and Q not equals to 0 is called a rational number. Once again say that what is the definition of that rational number here? A number which can be expressed in the form of P by Q. P by Q means that is nothing but a fraction form. Understood ma? Which number we can be expressed in the form of P by Q, and here P and Q are integers. Children, we know that integers means positive numbers are there, negative numbers are there, and in the same way 0 also there. Okay, so including these three here, P and Q are integers and Q not equals to 0. The condition is Q not equals to 0. That kind of numbers are known as rational numbers. Understood ma? And here the set of rational numbers denoted by a letter Q. What is that? Capital Q. The set of rational numbers. Set of numbers denoted by one of the letter, no? So what is that letter ma here? The set of rational numbers denoted by a letter Q. What is that ma? By a letter Q. Okay, why? Because here actually natural numbers denoted by the letter N. Why? Because the starting letter of the word natural is N. That's why the set of natural numbers denoted by the letter N. And come to that whole numbers, the set of whole numbers are denoted by the letter W. Why? Because the whole numbers starting with the letter W. And come to that integers, what we learn ma? Integers, the set of integers are denoted by the letters I or Z. Here I is the starting letter of integers, and in the same way Z means here integers came from the word Zehlen, German word, okay, which means to count, no? That's why here integers denoted by the letter I or Z. And in the same way here rational numbers, here also you may get the doubt, here rational numbers starting with the letter R, no? Then here why we did not denote this one with R? Why? Because here see that rational numbers always defines that quotient. What is that ma? Quotient. That's why here this one denoted with the letter Q. Here Q is nothing but quotient. Understood? That's why here Q is equals to here set of and so on minus 3, minus 2. Here rational numbers also there, no? Minus 1, minus 1 by 2, 0, and here 1 by 2. 1, 2 and so on. Like this rational numbers, negative numbers we can observe that, negative fractions also we can observe, and here 0 means integer, positive fractions, and here positive natural numbers. So the combination of these all kinds of numbers, negative fractions, positive fractions, and in the same way integers. Integers means we know that negative numbers, positive numbers and 0. Along with that negative fractions and positive fractions also there, this kind of set is called set of rational numbers. Understood ma? Now here say that, so this is the definition of that irrational numbers, no? Now see here. Children, I told you know here 1 by 2, for example, the rational number is 1 by 2. Okay. Now here 1 is integer, 1 belongs to that is integer, and 2 is also belongs to integer. Now here why the denominator not equals to 0? Here p by q is equals to 1 by 2, for example. Okay, 1 by 2 means again you will get it as 0.5 something. 0.5, that is the quotient. Understood ma? That quotient is there, but here we can represent this one as again 0.5, that is a decimal fraction. Decimal fraction again we can convert into that fraction form. Understood? 0.5 we can be written this one as 5 by 10. After cancellation these two, again we will get it as 1 by 2 only, no? Understood? So that's why this is always depends on that quotient. That's why here the set of rational numbers denoted by the letter q. Okay. Now here come to this one. For example, p by q is equals to 1 by 0. Why we should not take that 0 at the place of denominator? Why? Because after cancellation, see that 1 into 1 is equal to 1, 1 into 0 is equal to 0. Again what you will get here? 1 by 0. After again cancellation, 1 ones, 1 zeros. Again what you will get ma here? Again and again you are getting the same number as the resultant. 1 by 0, 1 by 0, 1 by 0 like that. For example, 2 by 0. After cancellation also again you will get it as, we should not cancel that 2 by 0. We can't get that 0 into any number is equal to, again you will get it as 0. If you cancel that 0 with the numerator, then again and again you will get the same number, same fraction as that resultant. Understood ma? That's why here we cannot observe that quotient, particular quotient we are not getting here. Understood? That's why here in the denominator 0 is there, means this is undefined. This is undefined. That's why here in that p by q, q never equals to 0. The denominator never equals to 0. Understood ma? Now here this is the definition, and in the same way rational numbers are related to that definition. Now here see that 1 by 2, 2 by 3, like these numbers we are taking, no? These all are positive rational numbers. What are those ma? Positive rational numbers. Why? Because all are having that positive values only, no? Positive integers. Positive rational numbers. And in the same way here, minus 1 by 2, minus 2 by 3, minus 4 by 5 and so on. What we will call them? Negative rational numbers. We will call this one as negative rational numbers. Negative rational numbers. Understood? Now here children see that positive rational numbers, negative rational numbers, and in the same way what I told you here, here one of the point is there, that is every integer is a rational number. Children, what is the definition of that rational number ma? Rational number means a number which can be expressed in the form of p by q. But here integers means what? Minus 2, minus 1, 0, 1, 2 and so on. These are integers. Actually here rational numbers definition is a number which can be expressed in the form of p by q. But here p by q form is not there. Then why we can say that all the integers are rational number? How we can say? Here the reason is every integer, by taking 1 as the denominator, we can express that every rational number as every integer as a rational number. Understood ma? By taking 1 as the denominator, every integer we can express as rational number. That's why here what is that point here? That is every integer is a rational number. Understood ma? Now here say that why ma'am here we taken that only 1 as the denominator, except that one if you will take that any other number, the value may be changed. Yes or no? The value remains changed here. If you will take that only 1 as the denominator, then the value always remains same. Here minus 2 by 1, again you will get it as minus 2, 0 by 1, again you will get it as 0, 1 by 1, again you will get it as 1, 2 by 1, again you will get it as 2. Understood? By taking 1 as the denominator, there is no change in its value. That's why here by taking 1 as the denominator, every integer we can express as the form of rational number. And its converse is not true. What is that? Every rational number is not an integer. Every rational number is not an integer. Not an integer. Why? Because integers means positive numbers and negative numbers, 0 only there. Here rational numbers means those are fraction form. Fraction form means that fraction form are not there in that integers, no? That's why here this is the condition. Understood, ma? Every integer we can express in the form of rational number, but every rational number is not an integer. If you will take that -2 is a rational number, yes, of course, -2 is a rational number, and -2 is an integer also. And in the same way, -3 is an integer, -3 is a rational number. Okay, 1/2 is a rational number, but 1/2 is not an integer. That is the condition. Understood, ma? So this is about that positive rational numbers, negative rational numbers, and integers are rational numbers. After this one, we are having equivalent rational numbers. Children, already we learned, no? Equivalent fractions. So same concept apply here. Equivalent rational numbers. Equivalent rational numbers. Equivalent rational numbers means equivalent fractions means what I told you, that here the value of that fraction what we taken after cancellation, after that taking simplest form, that value should be equals to that given fraction. Then we can say that what fraction we taken, that is the equivalent fraction of that given fraction. And in the same way, how we can find that equivalent fractions? By taking multiplication or by doing that division. Understood? And in the same way, in the two conditions also we should take that same numerator, and in the same way denominator we should multiply or divide. Understood, ma? See that. For example, here 3/5 is there. What is that? 3/5. 3/5 equivalent rational numbers. For example, 3/5 is the given rational number. Given rational number 3/5. Now here equivalent rational numbers. Equivalent rational numbers. Now here 3/5, this one should be multiply both numerator and denominator by the same number. Then what you will get, ma, here? 3 2 6, 5 2 10. After cancellation again you will get it as 3/5. 2 3s, 2 5s. And in the same way, 3/5 multiplies with both numerator and denominator by 3. 3 3 is 9, 5 3 is 15. Next, 3/5 multiplies with some other number, 100 and by 100. Any number you can take. 300 by 500. 0 zeros gets cancelled. Again you will get it as 3/5. 3/5 multiplies with 15 by 15. 15 3 is 45. 15 5 is 75. Understood, ma? 45 by 75. Again cancellation by 15. Again you will get it as 3/5. Understood? So this is related to multiplication. Now here come to the division form means, first see that what are the equivalent fractions of 3/5. First see this. 6/10, 9/15, 300 by 500. And in the same way 45 by 75 and so on. These all are the equivalent fractions of 3/5. Understood, ma? These all values again same only, no? That's why. Am I clear to you? And in the same way come to that by division method, how we can express. For example, the number is 12 by 24. The given fraction is 12 by 24. Now here when we can say that those two also having that common factors, those two also having that, first we have to see the factors. After just observe that what common factors are there. Understood? Now here 12 and 24, we know that some common factors are there. Just say that 12 by 24 divided by 2. 2 is a common factor of 12 and 24. Now here 12 divided by 2 means 6. 24 divided by 2 means here 12. 2 12s 24. And in the same way, 12 divided by 3, 24 divided by 3. What you will get ma here? 3 4s 12 and in the same way 3 8s 24. 3 8s 24. Understood? And in the same way, 12 divided by 4, 24 divided by 4. 4 3s 12, 4 6 24. Clear ma? And in the same way, 12 by 24 divided by 6 divided by 6. 6 2s 12, 6 4s 24. Am I clear to you? And in the same way we can say that 12 by 24 divided by 12 divided by 12. 12 divided by 12 means 1. 24 divided by 12 means 1 by 2. Understood? From this one, what fractions are, what rational numbers are equivalent rational numbers of 12 by 24 ma? The first one is 6 by 12, 4 by 8, which is equals to 4 by 8, which is equals to 3 by 6, which is equals to 2 by 4, which is equals to 1 by 2. Understood? Now see that 12 ones, 12 twos, 1 by 2 we are getting. 6 ones, 6 twos, 4 ones, 4 twos, 3 ones, 3 twos, 2 ones, 2 twos. Again you will get it as 1 by 2 only, no? Understood? That's why here these all rational numbers are equivalent rational numbers of 12 by 24. Understood ma? Now here see that these are for that positive rational numbers. For example, here negative rational numbers are there. Then how we can take that? For example, minus 1 by 2 is there. What is that? Minus 1 by 2. To this one, here just take that both numerator and denominator should be multiplied by the same number. Again you will get the same rational number. Here say that 2 by 4 minus 2 by 4. After cancellation, again you will get it as minus 1 by 2. Understood? Now here say that minus 1 by 2 multiplies by 3 by 3. Okay? Minus 3 by 2, 3 is 6. Minus 1 by 2 into 4 by 4. Minus 4 by 2, 4 is 8. Minus 1 by 2 into 5 by 5. Minus 5 by 2, 5 is 10. Understood? Now here these all are that negative rational numbers, equivalent rational numbers of minus 1 by 2. Then how we can represent this one? Minus 1 by 2 is equal to minus 2 by 4 is equals to minus 3 by 6 is equals to minus 4 by 8 is equals to minus 5 by 10. After cancellation of that, after simplest form of all these rational numbers, again you will get it as minus 1 by 2. Am I clear my children here? Now here see that from this one what we can say, if that rational numbers are with positive sign, we will call them as positive rational numbers. And in the same way the rational numbers are with negative sign, we will call them as negative rational numbers. And in the same way here, just to say that negative rational numbers, for example here 0 will be there, then 0 by 2 is there. Is it a rational number or not? Yes, that is a rational number. Why? Because 0 by 2 means again you will get it as 0. 0 is a rational number only, no? 0 is a rational number. Now here 0 by 2 is a positive rational number or negative rational number? Children, we know that 0 is neither positive nor negative. That's why here 0 by 2 is neither negative rational number nor positive rational number. Understood? But 0 is a rational number. Understood ma? 0 by 1 is a rational number, but it's a reciprocal. Multiplicative inverse, we know that, right? It's multiplicative inverse, that is not a rational number. Understood ma? We will discuss about that one in properties. Okay. After this one, we are having that comparison of rational numbers. What is that ma? Comparison of rational numbers. We will discuss about that one in next video. Okay. Thank you all.